Okay, so let's start so that we get to the end on time. So first of all, I'm Davide Vanzo. I'm an application developer at ACCRE. I took care of doing all this stuff, so probably you're gonna hate me for a while. Hopefully, with time, you're gonna get used to it, and it's gonna get, hopefully you're gonna thank me because hopefully it's gonna simplify your life. So let's start with the why. So why changing? So there are a bunch of challenges when it comes to managing scientific software. The first thing is that our target should be that you shouldn't have to worry as much as possible without building and making the software that you want to use compatible with the cluster. So we should be able to provide the most of the components you need so that you can focus mainly on the science, so using the software. The problem is that scientific software can be challenging because it's usually a little more complex because there are a bunch of different softwares and each of them can be more or less well documented, and the installation procedure can be more or less clean. So it presents a lot of, and plus they may depend on a lot of dependency on a lot of libraries and other software. So preparing the whole environment in order to be able to compile, even if you want to compile it on your home directory, still presents a lot of challenges, and most of our users typically lack this kind of expertise. So well, I've never had to deal with compiling something in Linux. I've mostly worked on Mac or Windows, and everything, I just do my exe and everything works fine. Well, in a high performance computing scenario, everything gets even more complicated because on your own machine, or if you have one machine that is used within your own group, well, the amount of software that you need is relatively limited because you have, you do a certain kind of research and you use 5-10 different kinds of softwares. But on a shared environment like an HPC cluster, we have a lot of users, and each user comes from different disciplines. So we have users from the medical center, from physics, chemistry, engineering, and all of those may use the same software, like I'm thinking about Python or R, but they may also need particular software. So at this point, the software situation becomes a real jungle, because you may want a specific version of, I don't know, Python, because your script works with Python 2.5.11, and instead you say, no, I'm cooler, I want to go on Python 3, so I need Python 3.5. blah. And at that point, we need to be able to provide both at the same time. So it gets complicated. And in order for you to use the software that you need, as you should already know, you have to modify shell environment variables. So modify path and LD library path. Sometimes software comes with its own environment variable. So everything gets overly complicated. You can see that this does not fit the idea of you have to focus on using the software and doing science. That this sounds more like, well, I have to focus on making my own stuff working. So what we want to try, what you need, and we wanted to try to do, is to allow our users to easily search for the software that is already available on the cluster, and at the same time allow them to access quickly and efficiently. Okay. Please, if you have any question, just stop me at any moment. Don't worry if you hear something that you don't understand or you have any curiosity, just stop me at any time. So until now, how many of you are familiar with Setpkgs? You should know. If you are a cluster user, you should. Okay, so Setpkgs has been the environment manager that we provided on the cluster until now. So it's still there. It's not going to go away yet. This one has been a framework written by Alan, at ACCRE, and it has been on the cluster since 2001, so since the first cluster at ACCRE. The problem we start to encounter, and also some of the users encounter, probably you are among one of those, is that you don't have, just a second. Lost Windows. Yeah, there you are. Setpkgs works with a flat naming scheme. What does that mean? Well, you have, as you can see over there, you have Boost, the version, Python, the version. So the name of each package has to contain the software, the version, and whatever it depends on. Okay? It's difficult to search through the packages. The only way to search the packages is, well, I grep, so I pipe that. So I do package info, pipe, grep to, I don't know, I'm looking into Python, pipe, grep Python, and I get everything that contains Python, but that's not very efficient. And there is no software conflict control. One of the typical issues I have to deal with users is, well, how many of you use R? Okay, or even Python. How many of you use Python? 1, 2. Okay, so Python, R, more or less, they work in the same way, more or less. So when you hear R or Python, think of exchanging with whatever you are more familiar. So in either case, for both of those software, when you have to build a Python or R module, one of the things that you should do is to use the same compiler that has been used to build R. And if that module also needs some additional library, let's say there is something that is, for example, the MySQL interface in Python or R, if you want to build it against the MySQL client, at that point, all three, so R or Python, MySQL, and the module should be built with the same compiler. And finding it out through there, it becomes a little annoying because you see, for some of them, for example, you see Boost, which is a numerical library. It has, you see, it has been built with GCC 4.6, Python 2.7.0, OpenMPI 1.04. But it's up to you to select the right packages. And that's very error prone. And that was one of the main causes that we found out while, from the tickets that we got from our users. So that significantly increased the entropy of the software environment in a sense that, for example, in this case, in blue, you can see the compilers we have. Then I put R, and then I put some MPI libraries. But from a user perspective, it's hard, and even from my perspective, because, when I have to build for my own use, that gets a little annoying. The problem is, it's very difficult to find out which is which, okay? Which one has been compiled with what. So that Scalapack MPitch 2 Intel, which version of MPitch did it use? MPitch 2 Intel Ethernet or MPitch 2 Intel 14 Ethernet? Both. Okay? So the typical way in which in the high performance computing world, the typical way in which this problem has been solved is by using what is called a software hierarchy. Okay? So software is organized on layers. At the initial layer, you have the compilers, and we are going to support two compilers, GCC compiler and Intel compiler. Then, once you select a compiler, everything that is built with that compiler shows up. So, for example, if you select the GCC compiler, you will be able to load either OpenMPI 1.10.3 or OpenMPI 1.10.3-Roki. Okay? So you can choose between those two, but you will not be able to select the Intel MPI. This is a kind of a weird thing, but okay, you should be able, but it's a different thing. And as you can see, at the end, you have an application. I've selected a single application called Amber. Amber is a high-performance molecular dynamics simulation software. And as you can see, the module for Amber has exactly the same name, independently with the compiler it has been built, the MPI it has been built. So in every time the module is always Amber/16/16/16. And the reason for that is that depending on the way in which depending on the libraries and the compilers you select, you will be able to see only one of those Amber at any time. Does it make sense? So the software now, instead of being provided like a bunch of Lego bricks thrown on a table, okay, so in a flat situation, now they are provided as a stack, which is a tree-shaped stack. I've probably started using modules as a name. Don't get scared by the module, because packages and modules are exactly the same thing, just different names. Okay. Initially, in other HPC environment, the software that they used to manage software was called environment modules. Okay, it's the name of a software, which was written, now it has two versions, one in TCL and the other one in C. And most HPC, have you ever seen environment modules? So have you ever worked in another HPC cluster and had to do module avail or something like that? Any of you? Okay, that's good. Just to figure it out. So each module matches a module file, okay, that contains all the information required to allow the users to run that specific software that they want to use. So once you load the environment modules goes in there, reads that file, and sets the environment accordingly. And in the same way in which you did with Setpkgs, you can load modules and unload modules without going out of the terminal. So you can play as you want. The problem of environment modules is that it has minimal support for hierarchical modules. So yes, you can still set hierarchies so that, hey, show me only the software that has been built with this compiler or with this library. But it's not possible to search, for example. So it's very hard to search through the modules. A lot of supercomputing centers, what they did is that they have a web page, and so you have to go on the web page, find out where it is, then go in on the terminal and search, and then go through it. There is no software conflict control. What is software conflict control? Let's say that you use Python and you load Anaconda. Are you familiar with Anaconda? Anaconda is it's a distribution of Python that comes pre-compiled. You load Anaconda, and then you forget that you have loaded Anaconda, and 15 minutes after, you load Python, which is compiled on the cluster. And what happens is that at this point, if environment modules would not complain about it, it would allow you to have both Anaconda and Python on the same environment. The problem is that now when you say Python, which one of the two is gonna get executed? Anaconda Python or just a native Python? The same thing would happen, for example, by selecting, it would even allow you to select multiple compilers at the same time, multiple versions of a software at the same time. So you could have Python 2.4 something and then Python 3.1.5, okay? It would never complain. And obviously this is a problem because from a user perspective that can create errors that may be more or less hard to debug. So if we could have a software that manages modules in order that modules that conflict with each other cannot be loaded at the same time, that would be nice. Okay. So fortunately, a few years ago, they started developing this software. It's called Lmod, and it's developed at the Texas Advanced Computing Center by Robert McClay, and it's getting more and more momentum. The main difference between the two, so the other one is still alive. The main difference is that this one is actively developed. Environment modules is a kind just in maintenance mode, so there are no new features that get put into there. Instead, here there is a new version every 3 or 4 days. So if I find out a bug, I can just send them an email and say, hey, I found a bug last week. I sent them an email and say, hey, I think I found this. And I say, yes, it's a bug. Half an hour afterwards, say, hey, I just released a new version. Go in and test it and see if it works. Nice. This one has full support for hierarchical modules. It has also full conflict control. So we will try to minimize you loading packages that conflict with each other. And it has additional features from our perspective that would allow you to simplify your experience with the cluster. So here I've reported the two most important URLs for Lmod. So if you're curious to go and see it, we are currently writing, so on our website we have already put our own Lmod help page. It's gonna be a minimal web page because the Lmod docs are very well written. So they have an initial user and then an advanced user section. So we will provide you all the information you need, but if you feel like you wanna use it for all its potential, you can simply go into their website and there is a lot of things. And if you need something, you can also let us know and we can point you in the right directions. So what are the essential commands you should know? So until now, you have used Setpkgs and package info. That's all you need. Now Setpkgs and package info, so now you don't have two different commands. Everything responds to a single one, which is module. Okay? And depending on what you put after module, you get different behaviors. So the first one is, how can I show me the software I can select from? Okay, show me the list. And that command is called module avail. So let's see what it does. So I'm on the cluster, nice and clean. If I do module avail, you see now you're not gonna get any more vertical list of multiple pages of software. You're gonna get a nice table, okay, with the software. And as you can see, this layer of this table is called core modules. So core modules are either compilers or software that is distributed as binary. So for example, MATLAB or Java, CUDA, all that kind of thing, okay? So as is, so now I don't have any module loaded. As is, this is the set of modules I can choose from. Okay. So how can I load a module? Well, the command is obviously module load and the name of the module I want to load. So let's say that I want to load the GCC compiler. So I do module load GCC. Okay. Here. Yeah, let me see. Okay, so if I do module load GCC /5.4.0, that allows me to show you a very useful feature that was not present with Setpkgs. Are you familiar with the tab completion on Bash? Okay, who is not familiar with tab completion? Do you all know what it is? You push tab and it automatically completes the work. So in Bash, let me just. So in Bash, if I do, I don't know, the old Setpkgs, I don't need to write the whole Setpkgs. I can do set, hit tab. If I hit tab 2 times, it shows me all the options from which I can choose from. Okay. So if I start adding letters to it, well, no, Setpkgs is a bad. Let's say Python. You see, I haven't written it. I've simply hidden tab. So if I hit tab, it completes the line with the only options I actually have. The same thing happens. Sorry for the. I can't see my screen, so it's like a. The same thing happens with Lmod. So I can do module load, and I don't need to write the whole GCC thing. So I can do capital G and hit tab 2 times, and you see that the only thing that starts with G is either GCC or the whole GCC. So it can be GCC /5, and now if I hit tab, hello, well, now if I hit tab, it will automatically complete with the remaining part of the string. Okay, so that's very useful for long names. Okay, and in this way my GCC is loading. So if you don't believe me, yeah, I can do GCC version. Okay, and you see why I have the 447. Okay, you see that you see that now the GCC is the 540. It's the one I have selected with Lmod. Okay, the other one is module unload, to remove a module. So if I now go back into my thing and I do module unload GCC and then I hit tab, missing an N here. And then I hit tab, you see that I can select GCC 540. Oh, and now if I do again C++ -- version, you see that it is the 447 that comes with the operating system. Okay, so there are no more modules loaded. You can also remove all the modules from your environment, which is the equivalent of the Setpkgs -R. with module purge. So if I do, I don't know, let's say module load okay. One of the features that Lmod has and Setpkgs did not have is the capability of, you can query Lmod and say, hey, Lmod, show me all the modules that are currently loaded in my environment. To do that, the command is module list. You see, now what it printed out is only the modules that are currently loaded in your environment. You see that there are a bunch of modules that are in gray instead of being bright white, and they have an H on the side. That H stands for hidden. I'll explain you in a few slides what a hidden module is, but just don't worry about it if you see that H or those gray things. They are software as anything else. So if I now do a module purge, and I do a module list again, it says no module loaded. So I have completely wiped my environment to all the modules. Make sense? Cool. I'm lazy and I like Lmod because it is designed for lazy persons like me. So I don't want every time to type module load blah blah blah. So they provide shortcuts to that, and here is how it works. So the main shortcut is module is shrunk into ML. So if you type ML as is, what that means is module list. So back to my terminal. Sorry. If I do ML, you see that it gave me exactly the same thing as module list. Same output. If I put a module name after ML, that ML doesn't mean module list anymore, it means module load. So if I go back here, I do ml gcc -5.0, okay, and now I do ml. You see that the first one meant module load, the second one meant module list. Does it make sense? I see some confused faces around. Okay. Please stop me if something does not resonate with you, okay? The unload is even better. To unload a module, you simply have to put a minus sign in front of the name. So if you do ml-gcc /5.4.0 and you list it, then it says there are no modules loaded. Okay? Good. If you want to use module avail, you don't have to do the whole module avail. You can select it with simply saying ml av. So ml av, there you are. Okay, saves you fingers. Okay, so let's now take a look at what are the rules of the game. What I mean by rules of the game is how this thing works. So what you are allowed to do and what you're not allowed to do. And if you're not allowed to do, Lmod is going to stop you. So don't worry about doing crazy. So the first rule is you can have only one version loaded of a specific, one version of a specific software loaded at any time. So it makes no sense. Let's say that in the future we are going to have multiple versions of GCC. It makes no sense to have both version GCC 5.4.0 and GCC 6.2.0 loaded at the same time. It's even dangerous because you can mix and match the two, and that can create some pretty nasty errors, okay? Or the same thing is with Python or R. Make sense? So if you try to load, so for example, you see that, just to stay here, you see that those two ACML on the top there, there are two different versions. One is 531 G Fortran and the other one is 531 iFort. So the one is ACML is the AMD math library, is the equivalent of the MKL for AMD. And since it comes as a binary, so it comes pre-compiled, they have to tell you with which compiler they have built it. So the first one is built with the GNU Fortran compiler. The second one is built with the iFort compiler. As you can see, they have the same version. So from that perspective, those are two different versions. Okay? And it makes no sense to have them loaded both at the same time, because if you're building with GCC, you only need the G Fortran. If you're building with iFort, you only need Intel. Make sense? So let's say that I load. Okay. One thing that is worth noticing, did you see that D symbol on the side there of the second ACML? When you see a D in the module avail list, that means default. By the, no pun intended, but by default, the default version is the one with the highest version number. Okay? So in this case, the version number is I4, because you have an I, so it's alphabetically listed. So the second one is the default value. The reason why I'm telling you this is because it's very important for you to understand this and to take it into consideration if you need a very specific version of a software. So if you have a script that needs a specific version of Python or R to work, and you want that specific version, well, what you have to do is to do as I did until now, to specify the module name / the version, okay? But you can also say, I don't actually care about which version I'm using. I'm okay with using the default. So in order to do that, what you can do is, let me see. Okay, I don't have anything loaded. I can do ml ACML, okay? And now you see that if I do ml, the one that has been picked by Lmod is the default one. So if you don't specify any version, Lmod is going to select the default one. Take into account that we are gonna, once a year, I'll show you later, but once a year we are gonna add new software. That also means that you're gonna have a newer version of it. So if you use the default, take that into consideration, because when we deploy new software, you will have multiple versions. So at that point, if you have a Slurm script that calls a module without the version number, and we put a newer version there, your next job is going to pick the newer version. Just letting you know. Now, let's say that I want to load the other one. I don't want this one. I actually want, finding out where my cursor is I want this version here, okay? So what I do is that ml space, if I could only get this to work, cml / 531, no, that's the default, default. Okay, so now you see. Now, what I was trying to do is to load both ACML at the same time. Lmod knows that those two modules conflict with each other. So what he's saying is that, hey, since you cannot have them loaded at the same time, and you told me that you want this version, I am unloading the iFork version, and I am loading the G4 version. Make sense? So now, if you do an ML to see which modules you have loaded, you see that now I have the G4 version loaded. Make sense? And the same thing would happen with any version. So there is this thing. Other rule of the game is incompatible programs are also prevented to be loaded at the same time. And I already given you this example with Anaconda and Python. If you don't believe me, let's take a look. So, if I do ml purge, let me just clean up my environment. I do ml anaconda 2. Okay, so now if I do Python, okay, you see that now I have the Anaconda 4.3.1 version loaded. So this Python is the Anaconda Python. And let's say that I do ml gcc because I want to use the gcc Python and Python. You see that now Lmod knows that you cannot have Anaconda and Python loaded at the same time, although they are different software because they have different name. It's not Python, so it's not based on the version, it's based on name. But we told Lmod, hey, those two packages cannot be loaded at the same time. So in this case, it said, I'm swapping it. Yeah, sure, missing a T. And if I look at which Python, there you are. I have the 2.7.12, okay? Which is the one that I have selected with the Python module. Any question here? Everything is clear? Okay. So let's go to the third rule, which is, I already showed you the rule. If a version is not specified, the default module will be loaded. So be careful if you need a specific version. And even if you need a specific version, be careful, and you'll see later on why. So I always recommend, unless you have very specific needs, I always recommend to use the default version, but that's just my recommendation. The fourth rule is also very important to remember. With the exception of the compilers, so GCC and Intel, if you unload a module, the Lmod will unload only the module itself, not its dependencies. I'll give you an example. Let's clean up the thing. and clear, well, I'm not typing. Oh, well, I'm still in Python. Okay. Okay. So let's say that I load GCC and Python. Okay. So let me go on. So I load GCC. Now if I do a module avail, now you see, since now I have selected a compiler, once I do a module avail, I can see all the software that has been built with that specific compiler. So all the software that you see in the third layer over there is all software that has been built with GCC. Okay? So you can see that there is a Python there. So I can do ml Python. And now if I do a module list, you see that I have a bunch of dependencies there. It's easier if I reload it again. So if I load only GCC, okay, so those are the those are the GCC modules and the GCC dependencies. If I now do a module load of Python and I show the list, you see that now I have way more dependencies loaded, because that is what, so for example, libreadline, that's a library that is needed for Python in order to work. If I now do an ml minus Python and I list it, you see that libreadline is still there. So the reason why all the dependencies are still there, even if you have removed the software that loaded all the dependencies, the module that loaded all those dependencies, is because let's assume that you load Python and then you load something else. Okay, let's say R, because you need them both at the same time for what you want to do. And let's assume that both R and Python depend on libreadline, the same version. So when you load, you load Python, libreadline gets loaded. Then you load R. Since libreadline is loaded, libreadline stays there. It's already there. Now, let's say that you are going to remove Python because, well, now I don't need Python anymore. So you remove the Python package. If we would have told Lmod, hey, also remove all the packages that the Python package has loaded, what would happen at this point is that the R that you still have in your environment would not be able to find the libreadline dependency. Make sense? And you would end up with a broken software. It's going to start spitting out errors. So when you unload, all the stuff is going to remain there simply to leave the dependencies that were already there still there. As I said, one of the biggest functionalities for Lmod is the ability of searching for modules. So there are two ways you have to search for modules, depending on what you want to search. So the first one is, well, we have seen module avail, but I wasn't able to spot Python because it was hard to see. Well, so if you see, there is a lot of software there. This one is a software that you can load. So if you wanna just filter across the software that you can load, what you can do, you can still use the same module avail, but you can put the name, so in this case module avail Python, and what is going to show you is all the modules that contain that string in their name. So you see that here now you have Python, you also have Swig and Boost, because, well, the version contains Python in the name. Make sense? But you say, well, okay, but now we have filtered only on the software that we have GCC. It's available with GCC. Let's say that you just log into the cluster, you say, well, which, I don't know, which FFTW, which is the Fourier transform library, are available? I don't know. Okay? You don't know by definition. So in order to be able to do that, you also need a tool that allows you to search through the whole tree, not just through the visible part of the tree. So to search through the whole hierarchy, what you need is the module spider command. So let's see how this thing works. Let me purge the environment. And I go clear. So now ML says no modules loaded. And now, as I said, I want to search for FFTW because I need to build a software that depends on FFTW, and I want to see under which compiler it is available. So what I do is that I do ML spider FFTW, and here we are. So the first thing that you see is that this search is not case sensitive, because the result that returned me is, hey, I have found FFTW version 3.3.4. So that is the version. And if there were multiple versions of FFTW, it would have listed there in the list. So I found FFTW 3.3.4, 3.3.6, blah, blah, blah. And then you see Lmod tends to be pretty user friendly. So it says, okay, so now if you want to know where to find a specific version of FFTW, use the whole version. So now, if I recall again module spider, and I simply, well, obviously now I have only one version of FFTW, but let's say that that is also the one I'm interested in. Okay, if I now do the same, so module spider FFTW 3.3.4, now you see that the information changes, and what I want you to look at is this part here. Well, is that part there that says, hey, you can load it, you can get FFTW if you load the following modules. Either GCC followed by OpenMPI, or Intel followed by Intel MPI. Does it make sense? So what it's saying to you is that, hey, for this FFTW and for this specific version of FFTW, I have found two modules that correspond to FFTW 3.3.4 built with either GCC and OpenMPI or Intel and Intel MPI. So let's give it a try. So if I do ML Intel, just to change, and Intel MPI, MLAV, now you see that I have opened another layer, which is all the software that has been built with GCC and with that specific version of MPI, which is the message passing library. And you see that on top there is FFTW. If you don't see, you can still do ML FFTW, MLAV, and you see that it shows you FFTW built with the Intel compiler and OpenMPI and Intel MPI. Okay? So that's how you search for a module on Lmod. Questions? Okay. Another interesting feature is the following. Until now, what you have done, I mean, I don't know, how many of you have Setpkgs in their .bashrc file? 1, 2. There is no guilt in that, so just raise your hand. I had 2, so don't worry. 1, 2, 3. Okay. The problem of doing that is that, and we have seen from the large number of tickets that came in that all showed the same problem, is that you add something now and in a couple of years you forget about it, you load something else and you start getting errors and you cannot figure out why. You bang your head on the wall for a couple of hours, then you open a ticket with us, and most of the time where I go is into your .bashrc, and I check what you load in there. And 99.9% of the time, there is a module in there that is conflicting with whatever you want to use now. So you can still use module load statements into your .bashrc file. Nothing forbids you about that. Again, remember that you have added that into your .bashrc. However, there is a better way of managing modules, which is named collections. So a named collection is a way that Lmod gives you to save the state of your environment. So you can do the module save followed by a name to save all the modules that are currently loaded in your environment, and then to reload them again, so to reobtain the same state of your environment at any time in the future, even in future sessions, by using the module restore. So what module save is going to do is to create a file. So I have an example. ML purge clear. Okay. For example, I use Ember. Ember is the same that we have seen before, an MD software. So when I have built Ember in my home directory, I have selected a compiler, an OpenMPI, and all the libraries that Ember needed in order to be compiled. And I need to be able to replicate that environment every time I use Ember. So the way in which I did it is, instead of putting a sequence of module load into my .bashrc, because Ember is not the only software that I use every day, I have a bunch of other tools that I use. So what I did is that right after I finished compiling it, I did a module save Ember. And what that did is it created this directory here. So here I'm in my own directory. So you see that I'm in /home/Balsadri, which is my home directory. So in there, you're going to find Lmod created this directory called lmod.d. And in here, now it created a file called Ember. You see it over there? What does this do? Well, that one, if you open it, it contains a Lua script that Lmod can read in order to be able to restore your environment. So now I did a purge, so I have no module loaded. But if I do ml restore Ember, you see Lmod says I'm restoring it. And if I do mlav, sorry, wrong command, just ml, you see that now my environment, with just one command, the module restore Ember, my environment contains all I need in order to run Ember. Okay? That to me is a little more useful feature that using the .bashrc, because it allows you to compress multiple module load into a single command that you can call directly from your Slurm script or just from keyboard. And depending on what kind of work you're doing, you can select different environments at will. Okay, the way in which we now manage software is through another, we managed to build the software that we provide under Lmod is by using a framework called EasyBuild. So EasyBuild is a Python framework that allows to build software easily and reproducibly, so I can rebuild the same software in the same way at any time in the future. And the biggest advantage is that it is a community-driven project, so we are not the only one. So the idea is that it has GitHub repositories where you can contribute with your own easy blocks or easy configs, which are the file that EasyBuild needs in order to be able to build a specific software. And many HPC centers use it, so they inject the recipes to build specific softwares so that that software can be built anywhere. And that's a great advantage for us because we don't have to reinvent the wheel every time. We can simply use a recipe that somebody wrote in order to install it locally. Okay, and that's how we manage now how we build all the software. So one of the typical questions that comes from our users is, hey, can I get program blah installed on the cluster? Well, the software, the answer is, well, if the software you're asking for is already if EasyBuild already has the recipe for that software that you want to be built, sure, it's not a problem. We can take a look at it, and there is a good probability that we can easily install it on the cluster. If it's not yet available, at that point, you please submit an help desk request, and we'll see what we can do, okay? Because at that point, it's a little more complicated. Since we are using EasyBuild, one of the biggest advantages of EasyBuild is that it also builds all the dependencies. So on all the software that you're going to see under Lmod is not going to depend on the operating system libraries anymore. Everything, as you have seen, for example, before with Python and libreadline, until now, libreadline sits on the operating system. Now we build libreadline every time. The drawback of this approach is that if you think that, for example, Python has, you have seen how many dependencies Python has, okay? So every time you want a new software, all the dependencies need to be built if they're not available yet in the Lmod repository. So that creates a huge number of modules that would not be very helpful for you when you have to choose the software, because you will have to parse with your eyes through a huge list of modules. So in order to make the list of available modules a little more readable, most of those libraries that are not, and dependencies that are not essential for you to use directly, they are hidden. And if you remember those gray ones there, those are the hidden ones. It's very important, though, for you to know in case you want to build something. So if you have to build a software that depends on libreadline and you need it, well, yes, if you do a module avail, you're not going to see it there. But it may be there. So how can you see all the available modules, even the hidden ones? Well, if you use the --show--hidden option, it's going to show you everything. So let me show it to you here. So if I do ml, well, clear, ml av --show hidden, okay? There you are. So you see that now it's way bigger. So the list is crazy long. You see especially all those one over there, those are all dependencies. But the thing is that may be useful to you because if you need a libreadline that is over there in the middle in the second column, if you need that library, you can load it in your own environment to build the software you want to build by yourself. So similarly to how we did before with, so you can use hidden modules, show hidden also for module spider. So if you use --show hidden with the module spider, what's going to happen is that it's not going to search only, so if you don't use that option, it's going to search only through the visible modules. If you use the --show hidden, it's going to search also through all the hidden modules. Make sense? When you want to load a hidden module, so let's say that you want to load a hidden module, what you have to do is, with a hidden module, the tab completion does not work. You see, I'm hitting tab now, it doesn't come up. So when you're trying to load a hidden module, you have to specify the whole version, and the version has a dot on the front. The dot means that it's a hidden module. Last thing, so what are also our policies as far as software changed a little, not that much, but they changed a little bit. So as of now, 90% of the software available via Setpkgs is also available under Lmod. And I strongly suggest you to start using Lmod, so start transitioning now to Lmod, for the simple reason that when we will move to the new operating system, which is CentOS 7 on the cluster, we are gonna completely abandon Setpkgs. So I don't want any of you to find, to transition to CentOS 7 and say, oh damn, now this thing is broken, it doesn't work anymore. So start now so that you have some time to fix any bugs or problems, so that when the transition, and now that both Setpkgs and Lmod are available, so that you can still use Setpkgs for your production and start working with Lmod in order to figure out the bugs. And then once we transition to CentOS 7, everything is gonna go smoothly. Every year, so every 12 months, we are gonna provide a new set of compilers and MPI libraries. And every time we do this, the software that is more than 3 years old is gonna get removed. So there will be a life cycle of the software available for 3 years. Okay? So again, if you're using something that is the oldest version because your code does not compile with a newer version of the compiler, I would strongly recommend to start working on it, because after the 3rd year, that compiler is going to get dropped. So you're going to end up that you're not going to be able to compile your code. And don't worry, we are here to help you. So if you need any help to figure out why this thing is not compiling, we can provide this kind of service for you. And again, only the EasyBuild supported software will be installed. Everything needs to go through EasyBuild. So it may take a little longer if you request it. If it's not there, it may require to talk to us and see how to make it work. But that's the main big change we have on the cluster, other than Lmod. Our support channel, so to help you out in all this, to reduce the drama involved in the change, obviously we have our Lmod help URL, which is acre.vanderbilt.edu/lmod. I don't know if it's still active. We are working to make it work. And again, lmod.readthedocs.org, which is the official Lmod guide. We have also, how many of you are in the Slack channel? Nobody's on the Slack channel? Oh. So, do you know what Slack is? Okay, so go on that URL, sign up using your vanderbilt.edu email, join our Slack, and look for the hash software channel. I'm always there, so if you have any problem or you don't know how to do a thing, or you see some problems, feel free to just chime in there. I'm there, other users are there. I can help you out, they can help you out, so I'm trying to make this as more community as possible. Also because I like to hear your feedback. Again, the other option is the classical way of using our help desk service. So feel free also to open a ticket. So for us, Slack is not going to replace the ticket system. The ticket system is for more serious issues. So if it's just a very easy thing that can be solved with a couple of lines, we can easily do it on Slack. But otherwise, we have the ticket still there. So just feel free to open a ticket. Oh, one thing. When you join the Slack channel, please go into your profile and put your full name, because most of the users don't do that, and we see only the ViewNet ID, which is kind of annoying. I always like to know who you are by, first name and last name, other than the ViewNet ID. I mean, it seems a little more human to me. So I feel better to see names over there. Oh, I forgot to put another tick there. So if you have, since this transition can be quite annoying for most users, we are not doing, as you have seen today, we are every week until the 13th of June, we are gonna do one of those presentations. So it's gonna be exactly the same thing. So if you know some of your colleagues or your PI that they are active ACCRE cluster users, please tell them that there are other 2 appointments that they can attend in order to learn about Lmod, and we would love for them to come to learn, and if they have any questions, to make this transition as smooth as possible, and help us spread the word, because it's hard to reach everybody. We send email through the ACCRE forum, but most of the people, they just trash it. So we want to try to make it as easy as possible for you to go on, to work on the cluster. And that's it for today. So any question? And okay, so no questions. I'll let you go then. Okay, thank you guys.